Yes, in the previous video, we talked about this particular question as a practice question. We said write out the four quantum numbers of the last electron in 3p5. Okay, so what are the quantum numbers we are talking about? And these are the ones listed here: principal quantum numbers, the azimuthal or angular momentum quantum number, the magnetic quantum number, and the spin quantum number. Now, these ones on their own, I will explain all of these in the next video, but for now, we will try to solve this particular IJMB question. So we are looking for the four quantum numbers, sorry, of the last electron in 3p5. Okay, emphasis on the last electron, the last electron. Now, before you can even think about the last electron, which one will be the last electron, you must know some kind of principles like orbital principle, and well, we'll explain that later. But let's solve this particular question for now. So 3p5, we all already know that this particular 3 is the principal quantum number. Principal quantum number. And this represents the energy level. So it's on third energy level. While P is the azimuthal, and if you remember, we say S equals 0, P equals 1, D equals 2, F equals 3, like that. So P meaning 1, that means the principal quantum number, the N, the principal quantum number is represented as N, is actually 3 from here. Okay, the azimuthal quantum number, which is P, is represented as L, which is 1. Then, what other quantum number are we looking for? We're looking for the magnetic quantum number. And this only tells us the orientation of that orbital. So we already know that P has 3 degenerate orbitals. So if this is 1, then that means we have 0, -1, and 1. But now, where exactly do we have the last electron? So 3p5, we are to fit in 5 electrons here. So the first one goes in like this, 1. The second one goes in like this, 2. The third one goes in like this, 3. Okay. They fill up the orbital singly first, then before they pair up, right? So we still have 2 electrons left. Now the fourth electron will come in like this. Then the fifth electron, which is the last electron, will come in this way. So that means that the last electron actually came in here. Then the magnetic quantum number we're looking for is 0, this particular side. So the ml now, so the ml is used to represent magnetic quantum number. Okay, so the ml is 0. What about the spin quantum number? So if we give this particular one plus half, this is going to be minus half, plus half, and minus half. So this is the last electron we are going in for. We represent this as S. Okay, so this is -1/2. So we have looked for the principal quantum number, the azimuthal quantum number, the magnetic quantum number, and the spin quantum number. So this is all you are asked to give. So for the principal quantum number, the azimuthal quantum number, and all of these, how they relate and how we look for them, I'm going to explain in the next video. So our next video is going to be on the topic quantum numbers. Okay, and we cannot talk about this quantum number without talking about energy level, that is like Bohr's atomic model. So see you in the next video if you like this, and please share this video with anybody who is into chemistry or wants to learn chemistry, 100 level, IJMB, JAMB writers.